Hello everyone, my name is Nilesh Khanate. Welcome back to my channel. In this video, we are going to understand absolute basics of artificial intelligence, that is AI, from scratch. If you ever feel overwhelmed when you hear words like GPT, transformer, parameters, context window, don't worry, you're not alone. These terms can sound complicated at first, but I promise you, by the end of this video, you will have a clear and a simple understanding of what they actually mean. By now, you must have heard big names or big players in the market. That is ChatGPT from OpenAI, Claude from Anthropic, Gemini from Google, Perplexity. There are many other big players in the market. You must have end up using one of them, asking questions or drafting emails or generating some code. But have you ever wondered how GPT or Claude generates so unique content that sounds so human? Isn't it interesting? What exactly happening under the hood? So, is it really thinking or is it searching internet to get you the answers? To have your answers to all these questions, you need to watch the video till the end. Let's see. So, before we actually understand what AI is, we need to understand three basic terms that are the foundations of everything. So, that is one is data, and you have something called algorithm, and you have something called model. I hope the picture clearly explains you what exactly happening here. Now let's see in detail what exactly data is. What is data? Data is nothing but just an information. Data is what? It's information. It could be in the form of text. The text could be from internet or from the books, from the websites, or it could be in the form of images, or could have millions of pictures, or from the numbers. It could be real numbers, floating numbers, could be from the stock prices or the temperature. So this is all data. AI learns from data. The more data, the better it learns. So data is all about information. Let's say if you were learning a language, data is the conversation that you would hear. Similarly, if you were learning to cook, data is the thousands of recipes you read. That's all data. AI learns from data. Data is all it needs. So for a better performance of AI, it needs enormous data. So I hope it's clear to you. Now let's move on to our next term, that is algorithm. Now, what is algorithm? Algorithm is nothing but it's a step-by-step process of solving a problem is nothing but an algorithm. So it has certain set of rules that it follows in order to produce that output every time. So it's a method that computer uses to learn patterns. Now here in AI, algorithm is what it does is it looks at the data that we have already, and it learns patterns from the data, and from the pattern what it does, it adjusts itself. So how many times does it adjust itself? It adjusts millions of times. That's what algorithm is. So the process of adjusting is called as learning. Now what exactly is it adjusting? Adjusting some numbers, some neural networks behind it. They are adjusting those random numbers uh, millions of times in order to generate that output. That's They are nothing but weights or parameters. Don't worry about it, we will learn that in a bit. So that's what it adjusting. It adjusting to the numbers inside network, inside a neural network. So we'll talk that in further in next slides. Now let's understand the model. We understood what is data, we understood what is algorithm. Now let's see what is a model is. You hear it every time in every AI conversation. You hear these terms: data, algorithm, model. So now what is a model? Model is nothing but, now when when algorithm finish learning, that's what a model is. So model is what you get when algorithm has finished learning. Imagine you're studying for an exam for 6 months. What you do, you read some books, you watch some tutorials, or you attend some lectures, and you generate, I mean, you learn a lot of data. Now once everything learned, what your brain has every information in it. That's nothing but model. Your brain is like a model. So what is that? Studying for an exam is you're training your brain. Now, when you're giving the exam is, but what after studying everything, that's the model. So when people say GPT-4 is a model, it means that it trained on an enormous amount of data and from the algorithm. So the algorithm has studied enormous amount of data, and that's when you have GPT-4 as a model. And you have something called your Face ID on your iPhone. That is a model. That's an algorithm. It recognizes faces, and it provides security on your phone. Similarly, Netflix, the recommendation system on the Netflix, it's trained on viewing history. It suggests you what you like, what you enjoy. So that's what a model is. I hope it is clear to you. Now, before we move on further, let's see what we learned. So we learned data, and from data, the algorithm learned patterns, and this algorithm, once finished its learning, it produces a model. So model is produced from data and algorithm. So this is what it is. So we have data, we have algorithm, and then we get model. I hope it is clear to you. Let's move on to our next topic. So before we actually move on, we need to understand two main terms. One is training, and the other one is inference. Now, what is training? Training is a process of teaching the model. When you teach a model, that's nothing but a training, right? That's what we learn. Now, this training is very expensive, slow, and happens once. Now, what do you mean very expensive? Why it is expensive? Because it trains on enormous amount of data. You need a lot of data collection before you train a model. Now, what else you need? You need a high computing power. Now, why high computing power? We need GPUs. GPUs are very expensive. They cost you around $10,000 to $50,000. So that's why training a model is very expensive. Now you have something called, and you need time, right? You need to invest a lot of time in it, in order to train the model. Now, what is inference? Inference is that you is when you train the model, you get the answers. It's very cheap and it happens once. And you can ask it. Now, when you use ChatGPT, that's nothing but your inference. When you open a ChatGPT and ask a question, that's what inference is. That clear? So we have training and we have inference. Training is nothing but the process of teaching a model is nothing but training, and inference is when you actually use that training model, to get your answers. That's nothing but a model. Example: your Chat GPT it's a model, right? Now let's get deeper. People use AI, machine learning, and deep learning interchangeably. There are three different things, and they nest inside each other. AI is just a computer program that can learn, reason, or make decisions. So, the goal of machine learning or the goal of artificial intelligence is making machines do things that normally requires human intelligence. That's nothing but AI. So, like recognizing images, understanding a language, or making a decision. That's AI. Historically, the definition of AI is very broad. Now, if I tell you, in early days of computer science, every machine that did something that human can do, any rule based, and if it's following some rules and doing something, they considered it as an AI. So today we usually call them as rule based AI, or I would refer them as simple AI to separate them from machine learning. Now, what's the difference? Let's understand. Let me give you an example of a spam filter. In your email, if your email contains a word like lottery, then you specify a rule that it has to be sent to a spam folder, right? Now, it does very well. Yes, we can call it as an AI, but it does not learn new tricks unless a human, add few more rules to it, to the existing list, which is when it can perform. Otherwise, it can't perform. But machine learning is different. Instead of writing rules like you do in earlier days, what you do is you show machines some examples and let it figure out what exactly it is. So now that's what machine learning is. You teach them by showing the examples. You don't require any hand coding. You show 10,000 of photos of cat and 10,000 photos of dog, and that figures out its own. So that's what machine learning is. It learns from data. It learns from the patterns. If you take another example, think of a toddler seeing a dog for the first time. You point and say it's a dog, then you show another dog, and you repeat this process for a couple of times. Now the child starts recognizing new dogs even though they never seen a dog, that kind of dog before. That's what machine learning is. In a nutshell, the machine learns from data. You don't need to code the rules. So that's what it is. Now AI is not a magic. It's not thinking or it's not feeling. It's really good at understanding the patterns in the data. That's what we learn in algorithm, right? Now, let's understand what is deep learning is. Now, I told you, artificial intelligence, machine learning, and deep learning, they are nested inside each other. I hope it is clear to you. What is deep learning? It's a specific, a technique inside of machine learning. It's another technique inside machine learning. It uses something called as neural networks. I spoke to this when I was talking about algorithms, right? When we say adjust patterns, what it adjusts the neural network, it adjusts numbers. So that's what it is. We are right here, and it's a technology behind ChatGPT or image generators or voice assistants, everything that you use a modern AI today. So, but what makes it deep? Let's see. So that's what neural network is. See, what makes it deep? It has many layers. You see, it has layer one as input, layer two as out, I mean, layer two as hidden, and layer three as output, right? uh, did you, is it clear to you? So what makes it complex? The layers makes it complex. So a neural network is a system that's designed loosely inspired by our human brains. How the brain works. Your brain has neurons. Similarly, the artificial intelligence has artificial neurons. You have cells that send signals to your brain. A neural network has artificial neurons, that mathematical units that pass some numbers to each other. So in the figure here, I showed you only one hidden layer. However, there could be thousands of layers like that. That sends information, that passes information, that understand patterns. So now, deep learning just means there are many hidden layers. Deep means they were hidden, sometimes hundreds, sometimes thousands. Now, why does the depth matter here? Uh, each layer learns something more complex than the last. So let's say if you take an image recognition system, maybe layer one learns something called the edges of the image or the lines, and layer two learns something like it's a shapes, whether it's a circle, square, and layer three learns the parts of a body like nose, ear, everything. So it could be anything. Layer 4 learns faces. So that's what, the deeper the network, the more complex the pattern it can understand. So why it's many hidden layers? They are deep language models. They have hundreds of layers learning incredibly complex patterns in text. That's what it is. Now here comes the weights and parameters. Now what learning actually means, we have to understand this. This is very important. So every connection between neurons has a number attached to it. The number is weight. When training begins, all weight starts at random, at some random numbers. The model knows nothing. Then it makes a prediction, checks if it's wrong, and adjusts weights slightly to be less wrong than the last time. So it does this millions of times. It repeats, it adjusts itself. That's what we learn. By the end, the weights have been tuned so precisely that the model makes accurate predictions. So weights are nothing but the knowledge stored inside the model. That's why these weights are very important. They are the neural networks that has numbers in them. So everything is stored in the model in the form of numbers. When a people say GPT-4 has hundreds of billions of parameters, what they mean? They mean hundreds of billions of these weights or the parameters that together represents everything in the model that has learned. So the model's knowledge isn't the number of words it learns. It's all the numbers. It's stored in numbers. I hope it is clear to you. So the deeper the network, the more complex the pattern can understand. So we talk about GPT-4 has some 1 trillion parameters, stored inside it. So this is what deep learning is. I hope this concept is clear to you. Artificial intelligence, machine learning, and deep learning. Artificial intelligence, human-like tasks. They do human tasks. Machine learning, you show examples and it learns. Deep learning, neural networks. It's all about networks. It's all about hidden layers in it. It talks about weights. It talks about parameters. Weights and parameters are one and the same, though. So when it's why do you call it as a deep? Because there are many hidden layers inside it. That's how it learns. That's how it learns complex patterns. So that is what it makes deeper. Let's understand how large language model learns. A language model is a neural network trained specifically on a text. The only training task an LLM ever gets is to predict the next word. That's it. It has to predict the word across billions of sentences from books, websites, and conversations. This is a blessing in disguise, I would say. In the process of predicting the word, the model has to secretly learn everything else along the way. It learns grammar and structure, like it knows how to say how sentences are built, world knowledge, context and meaning. Here it understand. Let's say if I give you a bank, it could mean a river means a riverside or a money place. Even that language models understand tone and style, cause and effect, everything it learns. Now, LLMs don't learn by memorizing the facts. They learn by getting really, really good at guessing what comes next, and everything else emerges from that. So here in LLMs, large means it's very big in two dimensions. One is the amount of training data it's trained on, and the number of parameters or weights. So more the parameters, more capacity to learn complex patterns for the language model. So this is a neural network that's trained specifically only on the text. Its job is to predict the next word. So here, if you see look at the example, the Earth revolves around, it has to guess the word from the training data that it's received. It can give the answers accurately. It can predict your answer accurately. That's what LLM models, this is how they learn. I hope it is clear to you. Now, let's move on to decode what GPT is. Before we understand GPT, let's understand what ChatGPT is. ChatGPTs are two different words. One is chat and the other one is GPT. Now, chat is nothing but a web interface or an application that you use to interact with the GPT. So, a chat application is just a wrapper around your GPT. So, what is GPT? Let's see. Let's decode it. Now, G is generative, pre-trained, is transformer. So what do you mean by generative? Whenever you ask, when you open chat GPT and ask a question, it generates a new content. Every time you ask it a question, it generates a unique content. Do you think it copies from any website or any database? No, it generates a content from scratch. It always creates a new content. So Google search, what it do, it finds existing pages. Calculator, what it does, it just follows a predefined formula. GPT writes every time a brand new text for you. So now what is P? P stands for pre-training. So it means that it trained on millions of data, trillions of data before you ever opened the chat GPT and used it. So before even you ask your first question, it was trained on millions of books, websites, Wikipedia, code, science papers, everything it is trained on. That's why, since it's pre-trained, it can answer question that that you asked. I mean, you ask what is the capital of India, it gives you the answer. Any question that you ask, that it gives you the answer because it's already pre-trained. Now, transformer. What is transformer? It's a special design, it's a special architecture. That's a blueprint. It reason that it understand the context so well. So let's see that in a bit. What exactly transformers are, why it is important. So let's see. Transformer is a specific design or an architecture for how an AI processes a language. It was invented by Google in the year 2017. A team of researchers from Google published a paper titled Attention is what all you need. And this changed the concept of AI forever. Now, if you notice, AI existed before 2017. However, they were not smart enough. They were on a rule-based AIs. They work on certain rules. Like example, your spam filter or your thermostat. What are they? They are only work on rule-based. AI works by predicting what comes next. It looks at your input and makes a best guess. That's what AI is. However, before 2017, AI was very, very bad at it. Especially with a language. It processed words one by one. How? It processed the words sequentially. By the time it reached the end of the sentence, it had already forgotten the beginning. So if you look at this example, she kicked the ball, it was soft. Now, if I ask you what it refers to, as humans, we could easily guess what it is. It refers to the ball, right? Now, but the old AI models could not able to recognize it. It has forgotten by the time it reached the soft. So the transformer introduced something called as attention mechanism. Now, instead of processing the words one after the other, it does it processes them all at once in parallel. If you look at this, it processes the words in parallel, and it can pay attention to the words from earlier in the sentence, even they are far back. So that's what this architecture changed the AI forever. The transformer did not invent AI, however, it just made AI actually good at understanding a language by teaching to pay attention to the words. So just a small tiny change. It's why ChatGPT acts like a person instead of a robot. That's the architecture behind it. That's a transformer. Now, if someone asks you what is a transformer, transformer is nothing but it's an architecture. Now, it uses something called attention mechanism that identifies the words all at once. It processes the words at once simultaneously. They don't look at the words sequentially. However, they look at the words parallelly at once. So that's what it makes very special. See, if you look at this, ChatGPT, Claude, Gemini, every major AI is a concept of transformer. They work on the concept of transformer. Let's understand how a model reads your text. Now, this is something that surprises most people. Now, what is a token? A token is a basic unit of text that a model processes. A token is roughly a word, but not always. What we do? We read words. However, model reads tokens. Long or rare words are split into multiple tokens. Like if you look at the word Kubernetes, it's split into three or more words. Chat GPT, again, three tokens. Similarly, you have spaces, punctuation, special characters are also considered as tokens. Now, this process of splitting the text into tokens before the model reads it, it's known as tokenization. Very, very important. What is it? It's splitting of words into tokens before the model reads it. So your model does not read your raw text, it reads only the token IDs and token numbers or token numbers. If you look at this example, hello, how are you, might look like this as tokens. Now, you also need to understand uh, the vocabulary. Now, what is vocabulary? It is a complete list of all possible words the model knows. Now, think of it like it's a model's dictionary. GPT models have a vocabulary of about 50,000 to 100, 100,000 tokens. If the word is not found in the dictionary, it breaks that word into tokens or pieces that that it could understand in the that it has in the vocabulary. Tokens matter for three practical reasons: cost, speed, and limit. Now, AI APIs charge per token. More the tokens, more is the cost. Tokens are a money you're spending on LLM with every interaction you make with them. LLM companies like Anthropic, OpenAI, and Google charge based on tokens, both the tokens you send in and the tokens the model sends back. More the tokens, higher is the cost. For instance, a 500 word prompt costs very little, but output tokens are about 4 times more expensive than the input tokens. This is because input tokens can be processed in parallel. That means it's very fast and cheap. However, output tokens are generated one at a time, and each new token requires the model to run a full pass again. That is very slow and expensive. I hope it is clear to you why the token costs you, right? So for every token, you're paying money. So what is speed? Speed is more tokens, the slower is the response. LLMs generate text token by token, basically one word at a time. More the tokens, more is the waiting. For instance, a short 100 token answer returns quickly. However, a long 2000 or 3000 token answer might take much longer. That's what the speed is. And let's talk about limits, which is very, very important. Now, it is the maximum number of tokens that model can handle is nothing but a context window. A context window is the maximum number of tokens a model can see at a time. So that is context window. Let's see it now. Context window is the LLM's current working memory. LLMs have no persistent memory by default. The model does not remember your last conversation. Every time you start a new chat, it's a clean slate. Products like ChatGPT simulate by injecting summaries into system prompt, but the base model itself has no memory at all. GPT 3.5 has a context window of 4,000 tokens, while GPT 4.0 has context window of 128,000 tokens. Similarly, Claude has 200,000 tokens it can see at one go. That's a working memory of the model. Now, everything in the current conversation counts towards your context window. That is your system prompt, your entire conversation history, the model's previous responses, any documents you paste in. Once you hit the limit, all the messages get dropped. The model literally forgets them. It has no memory outside the context window. For instance, a 2000 tokens is approximately a 500-page book that it can remember at once. That's the power of context window. The more the context window, the better the response is. Now let's see how actually the model produces the output, the text. So you have typed your question, it has been tokenized. The model has processed it. The model does not just look for one right answer. Instead, it looks at every single word it knows in its vocabulary. It calculates a probability for every single token in its vocabulary. And for what should come next. Let's say if you take an example here, the sky is could be blue, clear, dark. Every word or in its vocabulary it gives a certain percentage. Now blue has got 42% chance, uh, and the clear has 18% chance. Similarly, and so on, every word in its dictionary it assigns some value to it. So this is called probability distribution, assigning a likelihood to every possible next token. Then it samples from this distribution, picks one. So basically it picks here the word blue, appends it to the text, repeats the whole process one token at a time until the response is complete. That's how the response is built, token by token, word by word, each influenced by everything that came before it. What is temperature? Temperature is a number between 0 and 2 that you set either by using the platform or sometimes directly if you are using the models through an API, that is application programming interface. Now, if you set the temperature as 0, the model almost always picks the highest probability token. Results are consistent. They are always same, predictable. It's safe. However, it's a little boring. Now, if you look at this example, a smartphone is a mobile device that makes calls, sends messages, and runs application. When I set this to the temperature to zero point 0.1, similarly, if you set the temperature to 1.5, The model gives the answer in a creative way. So the same sentence, it's in a different, in a creative way. So if you see, it's a tiny rectangle of a lightning and a glass that holds your friends, your memories, and every question you have ever whispered into the dark. So there's a much difference between uh, a temperature set at 0.1 or 0 and the temperature set at 1.5. The model spreads its choices, picks from a much wider range of tokens. Results are very creative, they are varied. Now, you can see it's can give poetry, brainstorming, creative writing. You usually don't need to worry about these actually. The default works great, but now you know why adjusting temperature actually changes how creative the AI sounds. So, if you want the AI to sound very creative, you can set the temperature to high. Now, we have talked about what AI can do so far. Now, let's talk what it can't do, or more precisely, where it goes wrong. This section is just as important as everything else, maybe more, I can say. Now the first one is hallucination. So is when an AI model generates something that is confidently wrong. So when you ask GPT a question, it never says that it don't know. However, it generates something definitive and it's false. uh, it might cite a research paper that does not exist, or give you a wrong dates for historical events, or maybe write a code that looks right but with subtle bugs in it. Why does this happen? Remember, the model does not look up the facts. It generates the most probable next token based on the patterns. Sometimes those patterns lead to something that's statistically plausible but factually wrong. The model has no concept of truth. It has only concepts of probability. That is one of the limitations of the the current LLMs. So I always recommend you to verify the facts from the AI, especially for health or legal or financial decisions if you're making through the LLMs. And even ChatGPT or OpenAI, they also say AI can generate a false output, so you cannot completely rely on it. So there should be a human in loop all the time. Let's understand the next limitation, that is knowledge cutoff. What do you mean by that? The training data ends at a fixed date. Events after that date are unknown. What do you mean? So till whatever the date the model has been trained, it could give the information up till that date. That's it. If you ask GPT-4 about something that happened last month, or it genuinely does not know, it might guess, it might hallucinate, it might say, I don't have information on that. So this is why products like ChatGPT added web browsing to supplement the model with live information. But the base model, they are frozen in time. The knowledge is limited. Now, the next one is the stochastic outputs. What do you mean by that? Stochastic means random. AI outputs are not deterministic. The same input does not always give you the exact same output unless you set the temperature to 0, as we discussed. This matters for reliability in production systems. If you run the same prompt 10 times, you might get 10 slightly different answers. For creative tasks, it's great. However, for precision tasks where you need uh, deterministic, you need to account for its variability. Now, let's see the other limitations of LLM, that is bias. Now, AI models learn from human generated text, right? We fed the human data that already written, already existed. Humans have biases, therefore, models do have. If most training data represents one culture or one language or one demographic, the model will perform better for that group and worse for the other groups. So it might reflect stereotypes present in the data. It might be less accurate for the languages. It's all less of during training. That's why. This is an active area of research. So no model is perfectly unbiased. Being aware of this, makes you more responsible user of AI. So these are the limitations of the LLMs, the current LLMs. I hope the concepts are clear to you. We will also learn about prompt engineering in the next video. Until then, thank you so much.